warm welcome to all. My name is Dr. A.A.PACKIA, ANTONY, Associate Professor in the Department of Mechanical Engineering. I'm working in College of PSM, College of Engineering and Technology. So today we have see some basic informations about material characterization through machine learning techniques. So it is an interesting one. So we will see following slides. So first of all, material characterization is one of the predominant field in the engineering, because for a mechanical department, for civil engineering department, for aeronautical engineering department, for any departments, any engineering field, material characterization is the important role, because we have to select the proper material which can stand the particular conditions of applications. For example, if we design a component or a machine to withstand low temperature applications, for in the AERO cryogenics temperatures, so the normal material can't withstand, so it will become too brittle and tear itself. So we can in the role to design a material to withstand very low temperature. So at a low temperature, so it can't lose its properties. So in similar way, in the extreme case, so if we design a material or component or engine to capable at the extreme temperature more than 1500 degrees Celsius, 2000 degrees Celsius, 3000 degrees Celsius in the atmosphere, so we have to design the material for that applications only. So in if we go for the sea-oriented applications, so if we design a bridge or component or steel, so it can't corrode. So therefore, it should be have very high corrosive strength. So therefore, in that applications, we have to concentrate on the corrosion properties. So like that applications, we have to prepare a material for that properties. So like this, we can extend the all the applications of materials. So all the material applications having the characterization, that is a main important part. So because before going to the practical application, we have to characterize that material, so it is capable or not to withstand the particular application, whether low temperature or high temperature, the low pressure or high pressure, low corrosive environment or higher corrosive environment. So high strength and ductility, yield strength, ultimate strength, everything. So we have to characterize this. So it is not for a new technique. It is already more than 10,000 years back itself. Material characterization is going on, and so many number of researchers also available for the material characterizations part. So in that, what we did in the conventional way means, so we have to prepare a component by using any liquid phase method or solid phase method. So then we have to prepare a sample as per the ASTM standard. So then we go for a computerized, high accuracy, high calibrated equipment. So we have to test that material properties, whether the of its tensile strength. So we have to draw the particular stress strain curve. So in that, from the stress strain curve of the material, we can characterize many properties like Young's modulus, stiffness, elastic limit, yield limit, plasticity, ultimate strength, breaking strength, and overall toughness, and how much elongation it can obtain before failure. So all these characteristics we can characterize in the conventional way. In many number of researches and papers are available for the characterization part. So in this, the traditional method, so that is a equipment based method, consumes more time and more cost. It is essential but one. But if we go for the material characterization through the conventional and traditional method only, it is highly complicated and highly expensive and time consuming, and we can predict the more exceptional cases. For example, if we go for the lower temperature, we can't use that for material testing. So if we go for higher temperature, that's also it is impossible to test in a particular condition. So for that case, So we nowadays artificial intelligence applications is highly useful and helpful for all the areas of engineering. So as we told earlier, not only material characterization, so in all the part, so everyone know about that the artificial intelligence technique is highly helpful to reduce the time consuming and costly and effectively. So in that aspect, so we in this video we discuss about the artificial intelligence method, that is machine learning. So machine learning methods, how it helps to characterize a material. So everyone know that the artificial intelligence is similar to a human brain. So it developed based on the neuron techniques. So it if we give some characterization to train to learn the computer, so it can predict from the given value. So from the given value, so we can accurately predict the result. It is impossible in the conventional techniques. For example, in the machine learning part, there are mainly two classifications. So the supervised learning and unsupervised learnings are there. So if we give some input, so some data set related to material characterization, so it is based on the supervised technique algorithms and unsupervised technique algorithms. So it analyze the data and it understand by the machine. So then we give some the required target value. So it gives the prediction. So from the prediction accuracy and error value, so we can calculate the material properties using the artificial intelligence method. So in that artificial intelligence, machine learning is very much highly helpful to the machine learning analysis research. So in this slide, so we in the part we characterize, first one is material characterization and another one is artificial intelligence method. So in the material characterization part, so what we have to characterize. So I told repeatedly material characterization. So what is characterization? So first point is study of material properties. So material properties means, as we told earlier, so the ductility, stiffness, elastic limit, proof stress and yield stress, ultimate strength and toughness, so resilience. So all these material properties we have to study in the material characterization part. So not only the strength aspect, in the thermal aspects also, thermal conductivity and creep strength. So these are all some mechanical material properties. So to study the mechanical and thermal properties, so we have to characterize the microstructure of the material. Microstructure means we have to analyze in the grain structure. So how the grain structure will be dislocated from one point to another point, and any dendritic structure or laminar structure includes and intermetallic compounds formed in the grain boundaries. So from that material microstructural point of view, so the material properties will vary for that particular material. If we go for some heat treatment process, that is aging heat treatment and solution heat treatment, so the grain boundary structure and intermetallic compound formation and distributions are will be varied. So therefore, in order to study the material properties, we have to strong fundamental knowledge about the microstructural and basic thermal and mechanical properties. Not only thermal properties, even though the chemical properties, how it will react with the atmospheric air and oxygen and hydrogen. So what will be the output product? So that knowledge is we have to develop before we go for the material characterization part. So okay, good. So in this diagram also, so these concepts are explained. So first the mechanical testing. So for the mechanical testing, so every result, for example, if we get the tensile strength for a particular material 150 megapascal, so another condition we get 200 megapascal. So what is the scientific reason behind for the enhancement of the tensile strength? So it is analyzed using the elemental analysis. Elemental analysis means, so each element, for example, what is the major element, magnesium, aluminum, zinc, nickel, chromium, like that. So how much percentage available in that material, that is elemental analysis. and using the microscopic technology, using the XRD, sum, EDAX, everything. So we have to analyze the microstructural part. So not only the microstructural part, the electrical magnetic characterization also we have to study using the method. So then the surface analysis, thermal analysis. So all these things called as a material characterization. So once again I repeat. So the mechanical part and microstructure part, electrochemical part and magnetic part and spectroscopic part and surface technology and thermal analysis, electrochemical characterization, all these comes under the mechanical characterization techniques. So to characterize the mechanical characterization, so the conventional equipments like that, the tensile, computerized tensile strength testing and computerized XRD, some EDAX, EDS, so electronic disperse surface technology analysis. So and fatigue, high cycle fatigue, low cycle fatigue, axial due to the axial loading, due to the bending loading. So we have to characterize the fatigue, and then we have to analyze the creep properties of the material and hardness. Hardness means, definition of hardness means the resistance to penetration. If we scratch some high hardness material to the low hardness material, how much penetration will be occurred in that material. So we can analyze the hardness and tensile strength. Tensile properties, compression properties, we have to analyze using the computerized technique. UT machines are available in nowadays. So they using the computerized universal testing machine. So we can characterize the tensile, compression properties, and even axial fatigue also we can study for using this material. These are some microscopic testing components and analysis. So these are the conventional methods available to study about the material characterization. So what are the challenges in the traditional methods? In the traditional methods, so high cost. For example, if you go for the dynamic UT machine, so it is in terms of crores. So it is having 2 crore and more than that also available. So it is impossible to construct the machine by all. In the small scale industries or researchers or students, it is impossible. So high premium institute, high premium R&D industries only, they are having the high caliber equipments. So therefore everyone and every time, so we go for that approach, that facility and we can test is really it is impossible one, and also it is a high cost and time consuming only. So these are the some traditional methods challenges. Even though that challenges are available, so we characterize based on the high caliber equipment is mandatory to go for the machine learning approach, because we need some input. So if we give more number of validated calibrated equipment data only, so we can predict using the material characterization by using artificial intelligence method. So these are some traditional methods, challenges in the traditional methods. So then we go for the second part, machine learning. So as far as we discuss about some material characterization. So what is material characterization? What are the properties we tested in the material characterization, and what are the equipment facility available in the material characterization, and what are the limitations available in the material characterization we discussed. So we move for the second part. It is a machine learning, introduction to machine learning. So machine learning comes under artificial intelligence. So artificial intelligence means everyone know that. So without similar to human brain, so it predicts some outcome based on the learning methods. So to implement the machine learning, first we have to study about the data analytics, data science. So data science means we have to structure the data and remove the outliers, errors, and blank spaces, everything. So we have to characterize and frame the data very well. So we have to, before to apply the machine learning, so we have to study about the data science. So from the data science, we can calculate the mean, median, distribution, standard deviations of the given data. So then we have to frame let's say normal distribution. So then only the data will be able to use by the machine learning methods. Machine learning is based on it defined as learning the machine. So machine have to learn from our data, so it can able to predict some outcome. So this is a basic fundamental. So machine learning enables systems to learn from data. That is important. So learn, so it is more important, the word keyword learn. So we have to train. So because even though system is not a human, so it is a machine. So it have to learn properly. So to learn properly, we have to give proper data. So data is very important. So we have to give the proper data, and we then from the data only in the system will learn the correct result. Otherwise, we get the wrong result or more error results. Basically, two types of machine learning approaches are there. One is supervised learning, another one is unsupervised learning. Supervised learning means we have labeled data. So, for example, if we give some mango, this is a banana, this is jackfruit. So, from that data, so machine learned like that. So these are, if the figure like that, so it is understood that is a fruit. So then it have the label data. So the outcome also we have put some fruit. So the supervised learning, from the labeled data it can characterize. It repeat the algorithm. So it predict the outcome. What is the target value? So it is a fruit or not. Or example, cat or dog. Or example, spam or not spam. If you get the email messages, so the supervised learning easily predict the input message is belong to the spam message or not spam message. Spam message means it automatically goes to the spam folder. Not spam message means it will come under the input messages. So these are the supervised learning. So some unsupervised learning means without the labeled data. So it is used for clustering. So for clustering techniques we used unsupervised learning. So it didn't have the label value like that supervised learning. So it is I am not explaining the 100% of this data in this module because it is having more number of concepts and fundamental principles are there. So in the short duration, so I just revise and just touch the concept, that's all. So unsupervised means it is one of the clustering techniques. It didn't have the supervised data. So from the data it form into some group data. So then it predict the given output is valid or not. So see the classification diagram. Supervised learning it for mainly for classification, yes or no, binary. It is a spam or not spam. So for that also we can use supervised learning. Regression means continuous variable for the gradual increase of age and gradual increase of salary. It is a regression. So for that regression analysis also we can use for supervised learning. For the unsupervised learning, mainly for clustering. If you group some group of input data and we have to explore into the higher dimensional place. So then we classify the given data to the according to the required answer. So association and these are unsupervised learning, and semi-supervised learning is also there. So why ML for material engineering? So how we use the material machine learning concepts in the materials. So why we go for the ML for material engineering? So while using the computerized tensile test machine, so we get in terms of lakhs of data for a single reading only. So it is having 1000 to 2000 rows are there. So to handle larger amount of data and larger composition, if we go for the increase the material percentage and if we increase the environment condition, so we can increase the complexity of the data. So therefore to handle the large number of data set, so definitely it is impossible to do in the manual method, conventional method. It is highly impossible, and it is very inaccurate results we can predict, because human results it is not accurate value. So in order to handle this large data set, so the system, the artificial intelligence, the machine learning, so accurately predict our data, accurately study from our data and predict the results. For linear result, we can use the manual method, linear extrapolation, linear interpolation. So for non-linear curve also we can predict using the machine learning methods, fast predictions. So once we develop the data structured properly, so we can generate the result very fast to the upcoming data. So reduce experiments. So in order to, for example, without machine learning, so only conventional technique only we follow means. So if we go for the 100, 200 times of experiments need to characterize a material. But while we using the machine learning methods, so if we go for 50 or 100 data set, 100 experiments, from the 100 experiments we characterize the data, and if we give for the data to the machine learning, so it will produce a good result and higher accurate value. So therefore the number of experiments also reduced if we go for the machine learning for material characterization. So how the workflow, what is the procedure followed in the data machine learning means? First of all, data collection. That I told clearly, the data is most important. If we give the correct data, correct true data and validated data, so the data distribution, what is the mean value, what is the median, what is the skewness, what is the distribution, normal distribution, logarithmic distribution, like that. So data collection is more data collection, and future first one data collection. So we have to collect more number of data and in the correct accurate data. That future extraction, the data processing. It is another called data processing. So that's why I told how the mean of the data, how it is distributed, how it is distributed. If we have some outlier means what means? So if we get 0 to 100 value for all the ages, all the data. Suppose one data only the extreme value 10,000 in terms of lakhs. All other data are from 0 to 100. So that is outlier. So abnormal data. So we have to remove that outlier, and we have to check any outlier data is there, or missing data are available, or messy data are present in our data. So that is our feature extraction. And what is the input value, what is the target value, what type of machine learning, that is we go for supervised learning or unsupervised learning, which is we go for that material characterization. All these parties are very important. So next one, model training. Model training means if we choose supervised learning, so in the supervised learning, linear regression, support vector machine, support vector regression, and descent trees are there. So many algorithms are there. So if you take one algorithm, so we have to train the model. Model means that is every machine learning method having one mathematical formula. That is a sigmoid function or a tan function or 0 to 10 h function. So that mathematical equations will give the result for our data. That is called the model. So we have to train the model by using our existing data. So how we train? So after the one output, we can calculate the accuracy value and the error value of the model. So R square accuracy 99%, and error. There are so many types of errors are there: mean absolute error, mean square error, root mean square error. So we calculate the errors. So if we train the model number of time means the error will be reduced and accuracy will be increased. So what is the optimum model? So for that model only we can use to predict our new data. So that is the model training. So then validation also very important. If you have the matrix form, row columns are there, so many number of data, so we can extract one part of the data, one result. So what is a model result? We can choose randomly some another group of data, that is what is the accuracy. So we classify our total data into two sets. One is a training set, another one is testing set. For example, 80% of data we use for training, 20% of data we use for testing. So we can predict the machine learning algorithm predict the result from the 80% of data. So it gives result using the for the 20% result. For this is the validation. So randomly we choose the 20% for the first row. So we choose the another 20%, another 80% of the data for another result. So like that we can change our testing set data in the group of data. So then we can analyze all the data model results are same or not, which is the higher result. So like that we have to characterize and validate our model. So then after these parts are completed, so then we can predict our new data for the new conditions. What is the required material, or what is the required microstructure, what is the material composition, or material individual components. Like that we can give output from our machine learning. So data sources, so where we collect the data sources from the experiments. As we told earlier, the computerized numerical method automatically gives the Excel data, the experimental result, simulation data. If we go for simulation analysis, so simulation software, simulation results are give the so many number of data, iteration data, and the literature database. So it is impossible to do the experiment now, and the simulation for data. So we go for the standard Q1 journals, previous publications, researches, result. So from the literature database also we can collect the database. And the high throughput experiment, from the high caliber experiment we can collect the data. So these are the data source. What are the data source? Experimental result we can collect the data, simulation data, and previous literature, and high throughput experiments also we can collect some data. Input features. What are the input features given to the machine learning to characterize the material? What are the chemical composition of the material? For example, it is a AZ91 alloy. A means for aluminium. How much aluminium it is having? How much zinc component it is having? How much manganese component it is having? How much magnesium component it is having? So we can characterize the material chemical composition. This is the input feature, because in order to characterize a material, minimum 200, 300 type of material we have to give input to the machine learning. So for the raw material, the chemical composition is most important, because each material element gives some impact, and it gives some output to the for the particular material. Next one is processing parameters. So processing parameter means how much, for example, we do the tensile test, how much the strain rate. So if we conduct the tensile test using the 0.1 strain rate, so we can and some, for example, wear test we are going for characterization wear properties. So what atmospheric temperature we use for this test, room temperature, or 100 degrees Celsius or 200 degrees Celsius ambient temperature. So these are some processing parameters. So every test is having some processing parameters. So these processing parameters also we can give the input for the machine learning model. And heat treatment process, if we go for any heat treatment process for that material, so we can include this heat treatment process also as a input parameter. And we discussed microstructure. Microstructure is more important as a input features. So these are some input features to the material characterization: chemical composition, process parameters, heat treatment, and microstructure. So what is the output properties we can predict from that machine learning model? So yield strength of the material. Yield strength means if we apply the stress, so without increasing the, if we apply the load, so without increasing the stress, the strain value only increase. So that is a plastic deformation. So that deformation is called the yield. So how much yield strength for that material we having. And UTS means ultimate tensile strength. So the maximum tensile strength that material can withstand for that applications. So how much UTS can withstand, and how much the hardness value, bigger hardness value, how much the new material having. So these are the some output properties of fatigue life. If we study the fatigue characterization, fatigue life, what is the endurance limit, what is the endurance stress, endurance stress. If we go for the high cycle fatigue test, how much number of cycles it can withstand with before failure. And if we go for the low cycle fatigue, so how much number of strain limit for the particular number of cycles. So these properties we can predict using the machine learning very accurately. So not only that, the wear characterization, how much wear property for the material having. So these are some example of the output properties, not only limited to this. So we can given the output input data, so we can predict some required output properties. For my point of view, I put some limited examples I posted here: yield strength, UTS, and hardness, fatigue, and wear strength. So not only limited to that, for the all other material characterization also we can predict using the machine learning algorithm. So these are the some machine learning algorithm used to characterize a material. Linear regression, support SVM means for support vector machine, decision tree, random forest, XGBoost, CatBoost, ANN artificial neural network, that is comes under deep learning. So after the machine learning, deep learning is more complexity than the machine learning. So we are having the input layer and output layer. Without in between the input layer and output layer, there are so many number of hidden layers are there. So that comes under the ANN artificial neural network. So these are some machine learning algorithms. So these algorithms already developed. So if we give the proper data and we train the particular algorithm, means we can predict the new material result with some accuracy. So if we predict some material it having less accuracy, we didn't go for that composition and process parameters. So we can change the composition and change the process parameter to get the higher accurate value. So from that higher accurate value, machine learning characterize the proper material. Okay. This is the artificial neural network I told in the previous slide. There is having input layer, output layer. In between the input layer, hidden layers are there. So the input layer having the some parameters. So in the two previous slides, we analyze what are the input parameters, such as the condition. So this is the input parameter: chemical composition, process parameter, heat treatment, microstructure. So we put all the required input parameters in the input layer. So these are some weight functions. So this particular composition having how much weight in the another output. So this material composition having how much output in the another material. So these are some weight functions. From the weight function, it applies some mathematical function. So it develops another result. That is formed by a hidden layer. So if we increase the number of hidden layers, the complexity of the problems and analysis will be increased. So the result also we get good results. So these are some required output. So we can get the output: how much strength, how much hardness, how much fatigue life, how much creep life, how much wear strength. So we can predict the output layer. So this is a basic artificial numerical structure. So these are some case study for property prediction. So if you want to do in the audience, if you want to practice more in the using ML material characterization, so first prepare your data set and select the proper model and give the proper training to the model and test the data. Then evaluate the performance metrics, that is accuracy and error. So from that value, so we can do the material characterization using machine learning. So this is the most important point I have to give in this lecture. So this is the machine learning part. So this is one example. So I analyze the stress strain curve prediction using the ML method. So ML based stress strain curve prediction, high accuracy design support. So this is the microstructure of the material. This is some stress strain curve related results obtained from the ML analysis. So from that analysis, what is the experimental and predicted actual stress strain curve and predicted stress strain rate. These are some error calculations and the box plots and they are there. So from that values we can analyze the material properties. So this is one example. This is another one example. This is taken from the previous publications. So these are the input layer. This is the hidden layer type of classifier and the categorical data. So how the property will be obtained. So this is a normal distribution for the particular cases. So this also we can study using the machine learning method. This is a stress strain curve. This is a mean value. This is a data deviation and uncertainty the author produced. So not only the stress strain curve, the microstructure also predicted using this machine learning method. See these microstructure images. So if you give the image analysis, so in previous what I told is data, it's a linear data. So in that previous surface analysis, that is image analysis also we can perform using the machine learning method, but it is more complex than the numerical data. So these are some microstructure analysis done using the machine learning method. What are the advantages based on material ML characterization? This is cost effective, fast and multi-property optimization, accuracy, less energy consumption. These are some major advantages of machine learning based material characterization. Even though so many advantages are there, the limitations and the challenges are very important. Limitations means the data quality. Data quality, if we give any data, so machine learning algorithm predict some result. So if we give the wrong data or inaccurate data or unauthorized data means, so that is some very limitations. So because the data, input data, we have to concentrate more. We have to take some Q1 journal, reputed journal results and reputed highly calibrated equipment results. So for that data only we have to use for the machine learning. Otherwise, if the data is not consistent or not structured or not distributed well, means the results also not accurate. So that is if we go for the machine learning is waste. So therefore data quality is major important. And overfitting, underfitting data. So if we learn machine learning very well, so the concept will understood. In the short duration, it is not possible to discuss everything. So it is overfitting and underfitting are there. So overfitting also it should be avoided. So without giving the proper input, it will give some output. That is overfitting. And interpretability, if we go for the multiple repeated results, that repeated experiment also, we have to predict the same results. So these are some limitations, challenges are existing available in the machine learning. So if you go for the using the machine learning method, so we have to concentrate on this also. So feature scope material, we have to improve. Nowadays it is trending by using the machine learning method to characterize the material. So we have to enhance in the future also. The trend will highly increase. So if we apply the artificial intelligence method in the material characterization, gives a new era to the future generation. And digital twins without car driver, automatic car driving, and without train driver, locomotive pilot, auto train will be operated. So this comes under the digital twins. And autonomous material discovery, new material discovery also we can it is possible by using the machine learning methods. So now we come to the conclusion session of this lecture. So ML transforms material characterization into new era. So already we discussed in the apart from the conventional method, we can use for the artificial intelligence to characterize a material. So it gives a new era to the predict the new material in the future generation. And for impossible application also, we can predict using this ML method. Enhance mechanical engineering research, mechanical engineering to enhance, to escalate the mechanical engineering research. ML definitely will be helpful to enhance the research and invent a new material which is impossible to characterize in normal conditions. These are the some conclusions. Thanks for watching. Thank you. We'll meet again.